Okay, now we're recording. Welcome to the live stream. We're getting some more people. That's wonderful. Oh, hey, Adam. Today, I'm going to talk through, I'm not going to talk through the sample exam. I'm going to talk through the styles of questions you're going to get in the exam. Most of the questions we're going to go through today, I've already recorded in a previous video. I will bring up a Composite page, which has all of the questions we're going to go through. It's all stuff from past exams. I actually don't know if you have access to these questions now that I think about it. I don't know if Sienna made them available. These are a couple of sample exams we had from before, but not quite the same one as you've been given this term. So let me just go to Confluence 2511. Confluence. Oh, here it is. Confluence. So we're gonna go through questions, and yeah, as opposed to it being like a sample exam, it's just going to be like a bunch of different questions in the style of what we'll be asking. So you can have a look at this. It should be accessible to everyone. And if you want a more like, let's go through a past paper kind of video, then check out any of the three ones above that are linked to the top of that Confluence page. Okay, we got 6 people. All right, I can do that. So let's start. I'm going to share screen. Close a couple of things. All right. You should all be able to see that. Just give me a shout if you can't. So I've taken a bunch of questions and just put them under like what topic they're on. And these are, again, like the broad topics that we'll be assessing in the exam. And I can see the chat. Cool. Let's start. Aggregation and composition. This is something that was discussed back in around like week 3 when we talked about UML diagrams and domain modeling. And part of coming up with the UML diagram is identifying when 2 entities have some sort of relationship, whether that relationship is an aggregation or a composition. So what we have here, an online call contains breakout rooms. Aggregation, what's that? Composition, what's that? Aggregation is when we have 2 entities which are related to one another. And removing one from the other doesn't necessarily cause the end of the other's existence. So let's say you have a car, and this is the classic example that we use. You have a car has an engine. If you take the engine out of the car, both the engine and the car will still exist fine, right? Like you won't have any problems there. You could take an engine out of a car and it will just sit physically outside the car. Whereas in this example, if you have a breakout room, you have an online call and you have a breakout room, and sort of, semantically there's an association between breakout rooms and the online call that created those rooms. It's like if you take the call away from if you take the breakout room and separate it from the call, or if the call doesn't exist anymore, if you end the call, then the breakout room ceased to exist as well. So the answer to this one is composition, because of that. I guess you could call it like a dependency. But this is like a semantic dependency where it's like if you get rid of the online call, then the breakout rooms will cease to exist. That's question 1. There'll probably be a question like this in the exam. Okay, question 2, inheritance and generics. This is just like I guess a section of the course that is very theoretical in the sense of like being able to understand generics, being able to understand inheritance, class relationships, because you won't have like notes in the exam because it's all closed book. You'll need to kind of be familiar with this stuff. The main way to do that is just practice and just like go and code up some stuff. Like if you don't understand this particular example, go and copy the code get it compiling in your local IDE, and just like play around with stuff until it works, and Google a bunch of things because there's heaps of documentation online. So explain with reference to concepts surrounding encapsulation one problematic feature of the code. What's encapsulation? Well, one big thing about object-oriented programming is we want to be able to hide information. And the reason we do that is to avoid coupling where we don't need it. So let's say I've got class B here, which is a subclass of class A. And B and A are a couple, they're connected. But what I don't want is for B to be reliant on what's inside A, because if I then go and change class A, I have to then go and update class B. And that's the classic coupling idea, is you have, one thing, when one thing breaks, then another thing breaks along with it. Now, even though like this is a child class, so it's quite closely connected to it semantically, but again, it's like you want to keep things private. Even the children shouldn't know about them. So here, when we have protected int x equals 0, that means B can go inside and modify X. It knows about X, it can change it, it can update it. And that's problematic from an encapsulation point of view. Now, sometimes you might have protected variables, like public static variables or public static constants, I should say, are pretty normal practice in code. And because they're constant, it's like, well, they're not going to update. So that's fine. But generally, protected variables are a code smell. I think the linter picks them up and prevents you from putting them in your code anyway. So that's part A. Part B, which of the following statements is true, justify your answer? And we have a bunch of stuff about covariance and contravariance here, and generic types. And this is where like just being familiar with stuff in Java is quite helpful. And the best way to do that, practice and play around. So, okay, first one, it won't compile because it breaks covariance. Second one, it won't compile as it breaks contravariance. Third one, the code will not compile as generic types cannot be inherited. The code will not compile as a generic type cannot be accessed from the child class. The code will not compile for none of the above reasons. The code will compile or none of the above. Okay, so in this instance, you probably could just like copy it into your IDE and see if it compiled. Let's do that. I'm going to make a new file here called covariance question2.java. Paste this here. Let me share my IDE. Cool. All right. Now this isn't compiling because I haven't imported it. This is problematic. Okay. Let's just make this return new array list. Now, it looks like it's not compiling. If we go to problems, then this is an error, not just a warning. So this code isn't going to compile if we try to run it. And it says the return type is incompatible. Sorry, was there a second ago? The return type is incompatible with ae.foo string. Okay, that's interesting. Why might it be incompatible? Okay, well, it's not compiling, so we can rule out like a bunch of these already. Let's go through and see if we can process of elimination sort of rule out these possibilities. I'm just going to copy the parts of the question here. So covariance, contravariance, generic types, more generic types. And get rid of that. So the problem is to do with this list E here specifically. And so it says the return type is incompatible with ae.foo string. So covariance and contravariance are concepts in programming language and inheritance theory, where we say, if you are a subclass and you choose to override a method, and that's the thing we do a lot when we make subclasses, we take the original method, in this case foo, and then we decide to make a new version of it. So we overwrite the original functionality. That presents us with some challenges that mainly come around to this thing called the Liskov substitution principle, which we'll do another question on in a bit. And this really is just like the Liskov substitution principle, but instead of it producing logic errors in your code, this is going to produce a compile error, which is good. We like compile errors because they help us catch things early. And in this case, we return an array list in our superclass. And then in the subclass, we say, okay, now I want to return a new type, or want to return a list. And you think, well, lists and array lists are kind of, related, so that should be fine. That's not fine, though. There's a problem. And the problem is, according to the Liskov substitution principle, all subtypes, sorry, yeah, no, I was right the first time. All subtypes must be substitutable for their base type. So I should be able to say, BB equals new B string. And I should be able to say this is an A, right? Because every B is an A because B extends A. And then I should also be able to say B dot, or I should say array list, no string, list equals B dot foo, hello. Because all B's are A's, I should be able to treat this as an object of type A, which means when I call the foo method, I pass in the string hello, it gives me back an array list. But the actual implementation under the hood, right? This is a B at runtime when we take in our runtime polymorphism, it's returning a list. And a list, remember, is more generic than an array list. Like if you go to type definition, array list implements list. List is an interface that array list implements a bunch of methods, right? If we go to here, it says you have to implement size, is empty, blah, 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 a bunch of other stuff. So that's problematic, right? Because these are two different types. And what as covariance essentially tells us is that if you are in a subclass, you have to return a type that is the same type or more strict. In other words, you could return, like if you made your own subclass of array list, you could return that, but you can't go up the chain and return a list. So the answer is the first one. The inheritance breaks covariance, and covariance is to do with the return type. Contravariance is to do with the argument type, and in this case, the argument is the same, so it's all fine, and it's not going to break contravariance. But contravariance is actually the reverse. So you can become more generic in your arguments, but less specific. This is all just like the Liskov substitution principle wrapped up in a sort of, again, it's like a compile time check done by Java instead of like a logic error that will happen in your code. So if this doesn't quite make sense, then I would read up on covariance and contravariance. Again, a big thing in programming language theory. This is not just a Java convention. This is general to all inheritance structures. And it's all about the Liskov substitution principle, which we're going to talk about that in like 2 or 3 questions. So I'll save the sort of conceptual explanation for that bit. Are there any questions so far? I honestly not a big fan of teaching online because I don't know if I'm just talking to a blank wall, but I hope you're all listening, and I hope that makes sense. So just give me a shoot if it's not. We have someone here in person. Hello, welcome. Yep, come in. You're the only person here who's in person. I'm talking to 4 online people. Thank you, Alison. It makes sense. That's awesome. What's your name, sorry? Lincoln. Okay, well, thank you for coming. I appreciate it. All right. I'm not even present. Sorry, let me. I forgot even to present my screen. Okay, that's all good. More the merrier. Okay, can you see that all right? Yeah, I can change the, I can dim the lights or something if you want me to. Is that better? Okay, I'll try it. Okay. Let me know if that's a problem. Here we are. So we've done inheritance and generics. Oh, well, look at this. Liskov substitution principle. So we're straight into it. Okay. I want to do this on the whiteboard. I'm just going to see how good my camera is. Oh, yeah, it's all right. Yeah, it's fine. I can do this on the whiteboard. I'm just going to more inputs. HDMI laptop. Projector 2 is off. Okay, there we go. There will be a question like this in the exam. It'll be about the Liskov substitution principle, and you'll basically have to explain whether the inheritance is valid, and if not, if it is, why it is, and if not, why not. So here we have a class called flight, and we have a class called gold flight, which extends flight. And we have some preconditions, we have some post conditions. And what is the question asking? With reference to design by contract and the Liskov substitution principle, explain why the inheritance here is invalid. Okay, so we've been nice and told you that the inheritance is invalid, and you just need to figure out why. We know that the code compiles. So again, the stuff I was saying about covariance and contravariance is related to LSP, but the types are all fine, right? Like this is Boolean, so there are no contravariance problems, sorry, no covariance problems. This is age, and this is, int and strings, that's all fine. The types all match up. What about the actual logic of the method? And this comes in with our preconditions, our postconditions, and our invariants. Now, if you just take a step back and don't worry about some code, just think about like the idea of, let's say you have an agreement with someone or a contract. This is my contract. Let's say I hire a plumber to fix my bathroom. And in the agreement, they said, okay, the plumber's going to come and fix the bathroom on this day, and you need to let them in. And basically, there's things that I need to do as the person who is the client. And those are called preconditions. And then there are things that the plumber needs to do, right? The service that they'll provide me as the person who's paying them, and they're called postconditions. And you can think of like the class or the abstract data type or the API in this case as being, like here's our black box. And this is like the plumbing service. Now, if I don't meet the preconditions as the person who's hiring this plumber, they can it's like, well, you didn't, the more classic example is like, you buy a plane ticket and it's like, well, if you don't rock up for your flight, then you can't get flown anywhere. In the plumber example, it's like, well, if I don't let the plumber into the house, then they're not obligated to fix the bathroom. So you as the person calling the ADT or the API or the function or the class or whatever you want to call it, have an obligation to set up certain preconditions. After that point, the API has to guarantee the post conditions. Yes, I will fix the bathroom, or yes, I will get you to your destination in a reasonable time, or yes, I will return this function. Yes, I will, sum the numbers between 1 and 10 or whatever the function is supposed to do. So in this case, it's like, well, the function is supposed to book a flight if you meet these preconditions. That's designed by contract. Okay, now let's throw inheritance into the mix. And you can kind of think of inheritance as being like, imagine we came up with a new version of the contract and said, okay, here's the new terms and conditions, but you'd already agreed to the original terms and conditions. Like you agreed to a flight. But now when we make a subclass, we say, actually, here's like version 2, but I've subscribed to version 1. So version 2 has to be backwards compatible with version 1. And the reason for that is this thing called the Liskov substitution principle, where all subtypes have to be substitutable for their base type. So let's make another Java class here, q3.java. I'm going to swap my screen share. All right, here we go. Here's my flight class and here's my gold flight class. I'll zoom in a bit. There we go. I'm just going to say return true, both. Let's say public static void main string args. Okay, so I make a flight f equals new gold flight. So I've made a variable called f and it's of type gold flight, but I don't know that. Again, it's like when you create a subclass, you can typecast it to the superclass. I can say f is a flight, but under the hood, when we run the code, it's actually a gold flight. So anything in the book method will run this version, the overridden version that is dynamically binded to this class rather than this code here, right? That's how overriding works. Now that's all well and good, and we make a lot of use of polymorphism, but I think I'm dealing with a flight here. So when I say something like, f.book, what is it? Okay, well, the precondition is age must be greater than 0, name does not contain any spaces. Okay, well, I need to meet those preconditions. So let's say I am 30 and my name is Nick. And that's all well and good. But the problem is here, I've actually made it a gold flight. And the precondition is age is greater than or equal to 50. So I violated the precondition for goldflight.book, but I don't know that because I think I'm dealing with a version 1 of our class, our superclass, as opposed to the subclass. What does that do? Well, that causes undefined behavior because we've supposedly met the preconditions, but in reality we haven't. And that is a violation of the Liskov substitution principle, which is why the inheritance is invalid. How do you fix this? Well, you have to follow a set of rules. And this is, again, the exact same thing as what we've just discussed with covariance and contravariance, except it's to do with these sort of semantic preconditions that we've instantiated, right? The flight is booked, the bathroom was fixed, whatever. So when you have a subclass, you can only weaken the preconditions, which is to say, like, if I make a gold flight, I can change this to age is any number, right? Age can be -1, age can be, some random thing. It doesn't matter. And what that will mean is this line is still valid. You haven't broken the contract accidentally, because so long as you're complying to this rule, you will inherently comply to this rule. So we're allowed to weaken the preconditions. And it's like saying, I mean, not that it makes a lot of sense, but it's like saying, oh, you don't actually have to let the plumber into your house now, but you still let them in and it's fine. Okay. The other thing you can do is strengthen the post conditions, and this is like, you purchase a flight ticket and they're like, oh, we're going to give you a free meal, or we're going to give you a free blah, blah, blah. It's like you get something extra that you didn't necessarily have in the original contract, but you're like, okay, that's cool, that's fine. As long as it does everything that you expected it to do before. If in the subclass, suddenly the post condition has changed so that the flight is not booked, which is not very helpful, you're violating LSP, because in calling this method, I assume that I'm complying with the original contract. I assume that the flight is booked, but actually under the hood, those conditions have changed. But if you were to say the flight is booked, and I don't know, some log is updated somewhere, that's doing more than it needs to, which is fine, as long as you're complying with the original contract. That's LSP. Are there any questions? This is sometimes like tricky, and I try to explain it in as sort of real life terms as possible because it makes sense like semantically. But I know it can confuse people. Okay, let's keep going. Oh, sorry, I didn't see this in the chat. If the precondition for flight is greater than or equal to, and for gold flight is greater than or equal to 40, would that still violate Liskov's rule, 50 for flight and greater than 40 for gold? If the precondition for flight is greater than or equal to, and gold flight is greater than or equal to 40. No. So if you had, sorry, let me go back to the thing. If you had greater equal to 50 here, and then in the precondition greater equal to 40, that doesn't violate LSP because so long as you comply to this rule, you will comply to this rule, right? It's like, okay, to book a flight, I'm 55, and that's I assume that's the case for this flight class, and then I get to the subclass and go, okay, well, 55 is still greater than 40, so you're still all fine. Whereas if we had it the other way around, I'm 41, but then I try to book it, but it's actually saying no, you can't. Those conditions have changed on me, so that violates LSP. Does that make sense? Awesome. Thanks, Monish. Okay, let's go to question 4. I think we're up to. I didn't number these. This question is about concurrency. So UNSW has asked you to build a web-based system where residential students can select their rooms for a new year, but they know that when the system is built and deployed, as soon as the ability to select rooms is activated, everyone's going to DDoS the system and immediately select their rooms, and it's going to be really, there's going to be a lot of traffic. And we don't want two people to accidentally select the same room at the same time, because then they'll think, oh, I've selected this room, but then they actually haven't, and there's all this annoying stuff to sort out. Causing data or logic errors, corrupting data or causing logic errors. How would you design your web server to avoid this issue? This question was I remember when we ran it in the exam, people sort of, this is one of those questions where it's like you don't need to like apply a template too much. And sometimes I think people in exams can get so like, like you rote learn stuff and you rote learn this and rote learn that, and just I need to sort of regurgitate everything that I spent the last 3 days rote learning. It's like sometimes in the exam you just need to like think and give a reasonable answer. So what we have here is a web server. And this is just like a Flask server or an Express server or whatever you build your API in. And it's going to get a bunch of requests, right? Student, all selecting their rooms. And let's say it's a multi-threaded web server so that I can handle, let's say 2 requests at the same time. But what if those 2 requests, like I want to book room 103, and this request also wants to book room 103. And here's my database. And then it becomes a race, right? So, this guy over here says, I'm booking room 103. He updates it in the database. This is 103. And then old mate over here, imagine this is thread 1, this is thread 2. Okay, so thread 1 has booked room 103, and then 2 comes along and says, actually, I've booked room 103, and the person who comes last wins the race. And now we have this data corruption. So the way we can do that, the way we can deal with this is by implementing synchronization. Now, there's a lot of ways you could do this. Probably the best practice way would be to synchronize the update of the database record. Again, this is like databases and web servers, and this isn't like core content of the course, but just the idea of like, okay, well, we have this piece of shared data, and there's probably going to be something that's like, room.update, student, room.update student. It says this student is allocated to this room, and all you need to do is just say synchronize around that. So only one person can update the room at a time, which means the next time you know, this thread comes along and tries to update. It goes, actually, this room's already booked, and tells the user a message saying, okay, now you need to select a different room because someone got there before you. Even if those requests were within, 0.1 seconds of each other. So you can synchronize the update to the room, or you can just synchronize the entire web server. Right? Which means that you have all these requests coming in at a time, and you just process one request at a time. So the requests sit in a queue. Let me draw this again. The web server, all these requests coming in. And then you just say, okay, I can take one at a time. Do this one, then this one, then this one, so on and so forth. And that prevents you accidentally having a race condition. That's it. That's all you need to say. You could talk about the Singleton pattern, but it doesn't really apply here in the sense that, like, you could have your web server as a Singleton, like if you had a class web server, and then you could do the whole Singleton pattern thing as a, like a creational, like how it's created and stuff. But all this really, the question is really asking you is, do you understand synchronization as a concept? Do you understand that we only want one thread to access this this data, piece of data at a time, and avoid race conditions? Okay. Any questions on concurrency? Got some typing. When talking about synchronization, do we have to mention Singleton pattern? No. So that's what I'm saying is, like, you could, in this case, you would, I think when we marked it as well, it's like you wouldn't have to talk about the Singleton pattern to get full marks. Just the approach of synchronizing accesses to shared pieces of information, that's all you need to understand. This is a very like basic understanding of concurrency. The Singleton pattern is a way to, like, sorry, if you talked about the Singleton pattern, that would be fine, but you wouldn't have to, is what I'm trying to say. There will be times when there might be a question that's like, choose the right design pattern, blah, blah, blah. And you have to, like, and the Singleton pattern is the answer we're intending you to select. If it says choose a design pattern and it talks about concurrency, then there's a good chance the Singleton pattern is the one that you're going to want to select. But if it's just talking about, like, this sort of question where it's like, how would you design your web server? That doesn't need to necessarily have a design pattern. Okay. There's no more typing, so I'm assuming that I think everyone's question is answered. Cool, no worries, that's all good. Functional paradigm. This is again one that you could just put into your IDE and see what worked. Again, it's like what compiles, and then there's the sort of most semantically correct answer. So this is a function or some sort of what's it called? Lambda, that's the word. It's a lambda that takes in a number n and it essentially tries to calculate if n is prime. And so we have a bunch of options here. We have function, integer boolean, consumer, predicate, supplier, and some of these types are parameterized and some aren't. The thing we know about generics is that you can create an instance of a generic class, right? A class that has a generic type, but you don't actually have to explicitly state the generic type. Java gives you this thing. Let's say I make a function. Say function f equals new function. Sorry, I need to switch my screen share again. Window Q3. And I need to import function for that to work. Okay, it's going to come up with this thing that's like function is a raw type, references to generic type function tr should be parameterized. So it's saying, well, this works, but it's not very type safe, and it's not good style, and it's certainly not good design. So normally we should say, what are the types of in this case, the input value and the return value that get returned from this function. Let's go back to the complements. Actually, I'm going to do this all on whiteboard. So immediately we know that every answer that is parameterized is better than the answer that's not parameterized, right? That's just a use of generics thing. So then we have, okay, function, consumer, predicate, supplier. What do each of these mean? A function is like a toaster. You put something in, you put in bread, and you get out toast. In this case, and that's what the two parameterized types mean. This is the type of the thing that goes into the function. This is the type of the thing that comes out. And you think, well, that could work, right? You've put in an integer n, and it returns either false or true. It's like a toaster. Okay, so you have int here, you have boolean here. So function is probably one correct answer. What about the next one? Consumer. A consumer is a type of functional interface that only consumes. It takes in stuff, but it doesn't give you anything back out, right? It's like the Cookie Monster. And in this case, it takes in an integer and doesn't give anything out. Well, immediately we know that's not true because we return something. So it can't be a consumer. All right. A predicate. This is a big thing if you do any like formal methods courses and do like predicate logic. A predicate is a statement that is either true or false. So you can say like, you know, the sky is blue. That's a predicate. Now, I mean, like at any one time, right? The sky could be blue or not blue. So you can say, well, you know, this is like a function. We call the function and it will give me a value either true or false. In this case, a predicate takes in a value. It takes in an integer. And you think, oh, this might be useful because we can take in n, which is an integer, and then we return either true or false. There's no generic type here because the return type will always be a Boolean. That's what it means to be a predicate. And if you think about it, you think, okay, well, we know that this is just like a function basically, but we always get a bool back. And it makes a bit more sense to say a prime, you know, the function is prime is a predicate rather than just any old function. You know, any old function could do anything, whereas this is telling you something that's true or false. So you think, okay, maybe this is the most semantically correct. And then the last one is the supplier. Supplier is like, you know, Coles, they get their Apple suppliers. It's the type of functional interface, which is like the opposite of a consumer, where you say, here's our black box, and it gives me stuff, but it doesn't take in anything. It just, you know, gives and gives and keeps on giving. That's a supplier. So, okay, so probably this one is correct. This one is also correct. Also, predicate and function are correct, like syntactically, but they're not the best because they're raw types. And then predicate is the best answer overall, predicate integer, because that is the most representational of what, you know, this function is prime means. Any questions on that? Oh, okay. All right, test design. Oh, Sienna, do you want to do this question?
Oh, really?
Okay.
I haven't read it since.
I just saw you. Never mind. Okay, so we came up with the following test plan. To make sure our code is 100% correct, we write unit tests for everything at the class level and controller tests for everything as well at the system level. Here's an example of their test list for implementing battles. This is one again one of those questions where it's like, just like think about it and read the question and try and see what's going on, as opposed to trying to figure out what, you know, formula to regurgitate. And you can immediately see that both the test lists are identical. That's a problem immediately, right? You know, rule 101 of good design, don't repeat yourself. Okay, so we've repeated ourselves here. And if you said dry, you'd get a mark. The next step is to say, well, okay, why is this poor test design specifically? And you're like, well, you know, we want unit tests which test, you know, we will write unit tests to everything at the class level. We also need everything at the system level. You know, don't you want tests at both these layers of abstraction so that you make sure you cover all your bases? And the answer is, well, sort of yes and sort of no. And this isn't core content, but in terms of a possible alternative approach to testing, there's this thing called a testing pyramid. And again, it's like you wouldn't have to say testing pyramid to get full marks, but if you could sort of explain something that's a bit like this, there's just like a slightly more logical way to go about the test design. We say, well, we could have a bunch of unit tests to test everything, but then we only have a certain number of controller tests to make sure that all of like the key use cases or the key user flows are covered. Because controller tests are probably harder to write, right? Because they're at a high level of abstraction, whereas unit tests are just like testing individual classes. They're nice and easy to write. You can write them as soon as you write your class. So we have a bunch of unit tests, and then we have slightly less controller tests that cover the main use cases. That would be fine if you identify the dry and just the fact that this is poor test design, then that's also good. Okay. Oh, this is a question about me. In a few days, we run the auto marker and download everyone's exam repos. Again, this is another question which is like, it's not like a formula or something that is written in the lecture slides. It's just like, can you think about this and like give a coherent answer? I think most people who did this question did it well, but it's not immediately something that you're like, oh, here's this thing that I've been studying for the last few days. So what we have is just like a script that clones the repos. This is something that actually happened, by the way. It was very sad. When multiple Git clone operations are run in close proximity by the same machine, GitLab implements a protection strategy, which blocks further Git clones. But basically, GitLab has a thing to stop you DDoSing it, where you can only do a certain number of clones in a certain like span of time, and you have to wait like a minute or 2 minutes before you're allowed to continue making requests. So what that meant was some clone operations fail. When the exam auto marking is run, it is only run on the present folders, and around 30 students won't receive their exam marks because of this error. What was the flaw or flaws in this design? Explain 2 measures that have been put in place to mitigate this from happening. Really, like any reasonable answer, like check that you have downloaded all the students' repos before running the auto marking. Have something in place. Most people said something like, have something in place where if you fail to clone, then you wait the allotted time and then try to clone again. Or you have some sort of test that just like sanity checks all the marks are there before, this is all just like the Swiss cheese risk management stuff where you need layers in place to prevent the likelihood of, or to minimize the likelihood of something going wrong. So any reasonable answer is fine for that one. This one, all software development is maintenance. With reference to your project in a paragraph, also discuss the accuracy of the statement above. I remember this question was so popular because people like went on their HSE English high horse and started writing like essays. Please don't do that. There are plenty of good responses, but it's like this was interesting because it's one of those statements that's like very easy to take literally, and people who took it literally was fine as well. We still marked them the same, but like a lot of people were like, oh, well, obviously not all software development is maintenance because you have the requirements analysis stage and the design phase and the blah 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 phase, and it's like, okay, yes, that's true and that's fine. But particularly when you put this sort of thing into context about what we talked about in the unknown is like, you have to spend all this time maintaining software and dealing with problems and dealing with legacy code and infrastructure. And when you do the agile thing properly, it's like you do very little up front, which is not necessarily true. Like most of the time, and this is the thing with big projects, is like you're stuck in your castle for 2 years building the software, and then finally goes to market, and all the problems we talked about, where it's like, well, what if the market doesn't care anymore? What if the technology's moved on? Or all these things where it's like the work you did was redundant because you should have released incrementally and released earlier, and as a result designed incrementally, which is what we're really interested in. If you do it properly and if you design incrementally, then you spend a lot of time maintaining and iterating on your software. So maintenance and iteration really are the same thing in this context. So if you kind of explained, like, and some people picked up on this, but it's like, okay, maybe not all software development is maintenance, but the spirit of what this is a quote from one of the guys who came up with Agile and Scrum. The spirit of what this quote is trying to say is like, you spend all this time dealing with the system that you have built and maintaining it and improving it, and that is where the meat of your design and development comes in. is making new versions of an existing system. All right, so that's enough waffle. Let's talk about design patterns. Painting application. Oh, we have a PDF. I'm sorry I didn't prepare this. Actually, we did. It was fine. No, sorry. This is linked to last term. I will fix this up. We have a PDF which is a UML diagram. You might get a question like this, where you have to like analyze some sort of design and either talk about the design patterns or pick up what the design patterns are. It's not too hard. All you have to do is look at it and go, okay, well, the question says, identify the design patterns used in the implementation. Oh, I saw the word state. Okay, that might mean there's a state pattern. Okay, well, I see the word state a lot, so probably going to assume there's a state pattern. Okay, we have I think this is an interface. This might be like an abstract class called state. Okay, yes, we can pretty safe to assume there's a state pattern. We also see the word strategy, iTool strategy, that's an interface, and we have a bunch of other strategies that inherit from it. Eraser tool strategy, freehand tool strategy, circular tool strategy. Okay, well, there's a strategy pattern as well. Cool. That's part A done. Pick one of the design patterns and describe how the implementation relates to the key characteristics of the design pattern. So this one, you basically just have to look at the diagram and say, okay, well, let's say we pick the strategy pattern. Every single design pattern has some key characteristics. If you watch any of the other live streams, I go through what those characteristics are. I haven't had my head in this course all term, so I probably couldn't tell you what they are off the top of my head. But like for the strategy pattern, you have a series of strategies, and then you have a way to dynamically change between strategies. The classic example is like the restaurant from the Tute, where it's like, okay, we have a charging strategy, and we can charge people normally. We can charge people as if it's a public holiday. We can charge people as if it's happy hour, and your strategy will change depending on what the circumstances are. But the idea is you can dynamically chop and change between any strategy you like, and there's no constraints on I have to go from this one to this one to this one. That's a state pattern when you start introducing constraints on the transitions. So here it's like, well, our strategies are, what are they? I-shaped strategy seems to be like the super strategy interface. And you can probably say that in your thing as well. Okay, select box, select region, rectangle tool, circular tool. And if you've used like Microsoft Paint or anything like that, then these tools will kind of make sense to you at a semantic level. Eraser, plastic, image, and freehand. Okay, so they're all my strategies. How do I switch between strategies? Well, maybe a user on the user interface clicks a button and they choose that tool, and then we use that strategy. Done. That's it. That's your strategy pattern. What's the time? 4:53. We want to do some coding. I'll take a break, and what we'll do, we'll go until 5. We'll do a couple more theory questions, and then did you want to do the ticket one?
Yeah.
Cool. And then I'll finish with the GitLab one. Where are we up to? Design smells and event driven. Okay. There'll probably be a question that's around like identify the design smells in this code or something to do with design smells. So make sure you know those. A class that isn't doing enough work to justify its maintenance is an example of which of the following code smells. That's a lazy class. So this is just like you're reading some code and then you come across a Java file and you're like, oh, this is weird. This class isn't doing very much. I don't really understand what it's here for. And that's a smell. Remember, code smells are just like red flags or things that kind of make you go, oh, that's a bit weird. So what could that mean? And this isn't part of the question, but like you just need to select lazy class. What can that mean? Well, it probably means that someone's stealing functionality from this class. And then you have another class which is really overly verbose and there's too much going on. It makes all these calls and extra stuff that it doesn't need to. And this is like the training system Tute exercise from Tute 4 where you have to refactor by moving stuff into the lazy class. I'll talk about the other smells as well. But when code has sets of variables usually passed together in multiple places, this is an example of the code smell, not duplicated code, that's just duplicated code, you know, don't repeat yourself. Not lazy class, because we just looked at that. Data clumps, yeah. The way I like to explain this is like, you know, when if you've ever cooked eggs before, and then you get like eggs stuck on the frying pan, and you have this like disgusting clump of egg, and all this sort of like sticks together. That's kind of the same thing here, where it's like you have these variables that kind of stick together, and they sort of, it looks a bit ugly, and you kind of think that's a bit weird, and maybe speaks to some sort of deeper underlying problem. So that's the data clumps code smell. Duplicated code is just dry, and then inappropriate intimacy is like when two classes, you're like, they're getting a bit frisky, right? It's something a bit weird, you know, they're talking to each other a bit too much, and maybe there's some excessive coupling here. So we want to separate them, usually by moving functionality from one into the other, or just, you know, and a lot of these code smells, like sometimes you look at it and you're like, the design is just cooked. We just need to start again and rewrite the whole thing. Sometimes it's a matter of like you can refactor stuff and move, but sometimes it's like it was flawed from the beginning and you need to start again. Okay, event-driven design. This is all the producer-consumer stuff that I had the pleasure of talking to you guys about in week 9. It is in the test, so make sure you know it. Different types of events can flow through the channel. Consumers, so this is an important one where like producers and consumers can wear multiple hats. A consumer can act as a producer and vice versa. When an entity consumes as an event, it immediately produces another event. Consumers subscribe to a particular color of events which are created by producers. So here we have a producer who puts green events into the channel. Consumer C2 subscribes to those green events and consumes them from the channel. P1 also produces red events. And then we have C3, which is a producer and a consumer, and that consumes red events, and then it also puts red events into the channel. Just by looking at this diagram here, is there anything that's a bit weird? Yeah, right. So you have this producer which is producing events, but then those events, because they're red and it subscribes to red events, like it's getting the ones from P1, it's consuming its own events, right? It's like eating your own vomit, which is disgusting. And that's a problem, right? Because then you just get set in an infinite loop. So I don't think the question asks you what the, it just says explain the problem. So that's all you need to do. Okay, I'm not going to go through this question, but there will be a question that's along the lines of, here's a scenario, blah, blah, blah. You get given some context, pick the design pattern and explain the character, explain how, I've forgotten how we usually word it, but it's like basically explain how the key characteristics of the design pattern map to stuff that we've written in the question. And it'll be things like, I'm trying to give an example, but without or anything. Like let's say it's the observer pattern. You say the observer pattern has observers, it has subjects, or, you know, again, producers and consumers. Say, well, what are the observers? What is the subject? What is the notification? What is the state change? These are all parts of the observer pattern, and they'll be present in the problem, and you just need to explain, here's the element of the pattern and here's how it maps to the thing. Now, if you're doing this question and you're like, oh, like I chose the state pattern, but I can't figure out what the states are, then it's probably not the state pattern. So this is like, you can do a process of elimination where you're like, okay, it's not this one, it's not this one, it's not this one, whatever works for you. The main thing is that like you can explain say what the pattern is and then justify it. And if you can justify it, then it's probably correct. Sometimes we even like allow multiple answers. We like design the question where, you know, like there's one pattern in mind, but sometimes it'll be like, oh, this answer could also be correct. So basically, as long as you can justify it, then you'll be fine. All right, that's 5 o'clock. I'm gonna take a break, and we're gonna skip through to this design and programming question. Now, I do apologize for one thing, which is that the sample exam that we gave you, where is it? Not this one. Assignment to East Long Weekend. Sorry, here we go. Sample final exam. So here, we haven't given you a whole lot of multiple choice questions. The short answer we've just gone through. We'll go through one of these design questions if we have time, but you can watch the other recording if we don't. The questions will be much longer than this. This is just like a basic idea that points to some other like revision questions we've given you. But the programming questions, there'll be two of them. One will be about refactoring, and the other one might also be about refactoring, but it'll be sort of more build this thing and use design patterns. Sometimes we might tell you what the pattern you need to use. Sometimes we won't. But it won't just be like, here's this one thing you need to do and that's it. There'll often be multiple parts of the question. The reason for that is we find some students, like, they either get it or they don't. And it's like, they don't get it, then you've lost like 30 marks. And that's kind of, it's just like a bit tough, especially given how much work you've done for the course all term. So the point of having slightly longer questions that give you more opportunities they give you more opportunities to show that you understand the content. And some parts of the question are intentionally harder, usually they're at the end. And that's fine too, that's for the high achieving students, and they're usually worth much less than the easier ones that are just like, do you know the course content? So we're going to go through two of those now. And the first one is just like Lab 8, or a simplified version of Lab 8, I think. So, take it from me.
Do you have the code up?
Yes, yeah, it's in the VS Code.
Okay, let me just get used to the next computer. And so it's in question 12. Oh, okay, cool.
You can delete those other two.
So wait, did you go? Is this the solutions or?
No, this is the start.
Oh, okay, cool. All right. Okay, cool. So when you get a programming question, we find that, as Nick said, like normally people get it or they don't, kind of thing. And this might be like the exam stress, exam pressure, people getting to like reading the question, just like, oh my gosh, I have no idea where to start. I don't know what I'm doing. Like all the exam pressure that comes from, here, go and code something in this limited amount of time that you have. But hopefully what you can do is you can just kind of take the question one part at a time. And then remember that this course is also about design and not specifically, do I get the question, like, is the output completely correct? So even if you just have, something there that vaguely look like that you've gone try and implement this kind of pattern kind of thing, you will get partial marks. You don't necessarily have to get the question completely correct to get either no marks or full marks kind of thing. There is a middle ground of those kind of questions. In saying that, hopefully you've done Lab 8. If you haven't, this is a really good example of we've taken a lab question and we've turned it into a final exam question, and we've just tweaked the format of it very slightly to make it an exam question rather than, something that you'll have a week to do kind of thing. So this one specifically says use the Singleton and Decorator patterns to create a ticketing system to send receipts in different ways. The other thing is these two tasks are independent of each other. So if you did get stuck on the Singleton pattern, you could move to the Decorator pattern without it affecting too much. So basically the first part, there is a main function simulating 7 users all trying to buy tickets at the same time. Below is the current output of the program. It might be slightly different to your computer. So this part of the question is kind of just to start to get you thinking about what the problems are and how can we solve them with some sort of design pattern. So in this case, identify 2 correctness issues and explain the causes of these issues. So hopefully you can have a look at this bit of code and you can just, or this output, and go, there's 4 tickets left. There's another 4 tickets left, but we only had, we had 7 tickets to begin with. What happened to tickets like 6, like all of the other ones above it. And why have we emailed, like, why have we sent a receipt to 2 people saying that there's 4 tickets left? And then we can also see here that there's 1, 2, 3, 4, 5, 6, 7 different people, like all got tickets. Oh, wait, sorry. Well, yeah, it's simulating 7 users all trying to get the same tickets. If you go have a look at the code or whatever, there's only 5 tickets available. And so this is what Nick was talking about before, about the difference between using the Singleton pattern and using and having concurrency issues. So pretty much the 2 main issues in this bit of code is we have one concurrency issue, which is there's now 4 left, there's now 4 left. There's now 2 left, there's now 2 left, there's now 1 left, and there's now 4 left. That not coming out in a correct order is due to concurrency issues, which you can hopefully immediately think, okay, it's a concurrency issue, I just have to deal with synchronization of something in my system. And then the second issue, you can go, this one, like, there would be a lot of like correct examples kind of thing. But you can see that there's only 5 tickets available because once we've sold 1, there's 4 left. And we've sold 7 tickets. So that means there's probably some issue with there's 2 systems or 2 ways, 2 things that are keeping track of what is actually selling tickets, which would be the example of like when you would use the Singleton pattern, aka you have 2 things that are both keeping track of some number that we really only want one thing to keep. You only really want one instance to keep track of that thing. And so all you would have to put for this question is there's some concurrency issues with the number of tickets left, and they've sold more than the number of tickets available, which would be due to, you know, you don't actually have to say the correct answer. As long as you come up with something reasonable, then you would get the marks for this part. Cool. So the first part is get the Singleton pattern working. So in the first case, if this question didn't say it said use some design pattern to solve your problem, hopefully this first part of the question would give you some indications of what you should actually do. And this is a very classic example of the Singleton pattern. And then it says, make it so it produces this desired output, which, you know, if you read this part and were like stuck, then you could be like, oh, well, this is what it's supposed to look like. What are the differences between those 2 things if you wanted to go back to the first part? But essentially, you should not change application in Java at all. So make sure you read the whole question, because if you do something like that's explicitly against what we've said exactly what not to do, chances are it's that kind of thing that's then going to break everything and then cause you to lose more significant marks than like if you change the interface kind of thing, expect that you'll probably not get any marks for the auto marks for that section, because we can't test your thing if you've gone and changed stuff. So make sure you read all of the question. But it says you should not change application.java at all, except for the initialization of ticketing system or user. A basic test has been provided in this one in ticketing system. Any notes you wish to make regarding your code can go inside question 12. The mark breakdown for this question is as follows. So correctness 3, design 6 marks. So again, this goes back to this course is about design. It's not specifically about have you done the thing correctly. Because if you've done the thing correctly, but your code is all like complete spaghetti code and you have no idea what someone reading your code is like, what the heck are they doing, right? That's not what this course is about. This course is about, can I write some code so that it's maintainable, so that it's extendable, like write some nice code, and design patterns are just a way to do that. So the next, so this part's the next bit. So let's just go have a look at the code. So if you're a bit unsure about the code at the moment, the first thing we can do is we can go have a look at the code. So if I close these. Do you want me to save them? Okay, so this is in the same folder, but if this was me in the exam, the first thing I would do is I would go have a look at the code and try and work out what is actually happening. So we can open up all of these files up here, and then we have a bunch of receipts. Let's just look at the normal receipt to start off with, because if things all normally have the same name, we probably only need to look at one of them rather than looking at all of them. If we get confused a bit later, we can go have a look. So the first one's application. This is the thing that it says we're not allowed to change except for the first part. So 2 ticketing systems are actually created. How can we stop this from happening? So there's even a bit of a clue in the code itself. Because this is a lab question that was ported over, there might not be hints and stuff in the code. Like don't be something that's don't expect that to be something that will be there, but it might be. And we can see here, this is our problem 1. We have 2 ticketing systems that are both trying to deal with the same thing and are allowing 5 users each to book their tickets. So like, okay, well, that's a problem to start off with. We probably need to do something about this. Creates a bunch of users. We don't really need to know much about that. Sets their preferences. Don't need to know much about that. And then there's a whole bunch of starts that basically just say, go do the thing that I told you to do. If we go have a look in user, we can see that there's some stuff that happens. The stuff in user is not particularly, like essentially if you understand this part, you don't need to know the part in user. And hopefully that is evident from you from reading the code or looking at the question, because the question is more about the ticketing system rather than the people using the ticketing system. So you're like, okay, well, I care about the ticketing system part rather than the user part. So let's go have a look at the ticketing system part. So the first part is we can see we have a buy ticket method, and we can see we have a public constructor, which is the thing that's allowing this to happen. So hopefully in your back of your minds, if you're thinking, oh, okay, well, this is the Singleton pattern, that's something that I need to go fix because that's the Singleton pattern problem. And then the second problem is the synchronization problem of this buy ticket method. So if we look here, hopefully without even reading the question, which specifically points out this bit of code, you might already have in the back of your head of like, this is not the best design. What can I do to fix this? But let's start off with what it's asking us to do, which is fix the Singleton pattern. So hopefully, when you think about the key characteristics of a design pattern, the Singleton pattern is probably one of the easiest ones. You just have to change essentially like one method and add an extra method. If it's when we get to the Decorator pattern, I normally like to start off with the infrastructure stuff and then fill in the code later kind of thing. But the first thing we want to do is we're like, okay, well, we don't want other classes being able to do this. So the best way to is this from, yeah. So the first thing is, I might just make this a bit bigger. So first thing is, well, we don't want people to be able to do this. There's currently no code that does that, but that's not something that we want to be allow. So let's make this private, which hopefully you also understand is one of the first things you have to do when you create when you're implementing the Singleton pattern. The second part is we're missing some code in this line here. So we don't want to create a new ticketing system anytime we do the get instance. We want to actually return if it's already created, we want to return one that's already been stored. So the first thing we need to do is we want to create a private ticketing system. Oops. Command C. So we want to create a private ticketing system so that we can store it, and then we can do equals null. Sorry. Does what need to be static? Well, so it in the you're only ever creating like one object of the class. So static is when you have and I've yes, yeah. But in yes, sorry. Yeah, so what we want to do now is when we want to basically check that if this is if it's not null, then return this. If it is null, then yeah, create a new one and then assign it to this thing. So what we can do is if so if ticketing system isn't null, then we want to return our ticketing system. And then otherwise, we want to do our ticketing system equals our new ticketing system and then return our, whoops. So cool. We're missing one other thing on this class. Does anyone want to have a? Does anyone know what it is? Sorry, say that again.
Because when you're and that's only
yeah, so in that case, when you are just getting the instance, this returns on this line. So these two bits of code never run unless it's the first instance.
Exactly.
Yeah.
So now if you have the second
Yeah, so yeah, in this case, you'll end up, yeah, that's one problem. The other problem is that what I was we can fix that one if we have time, but in this question, it's only really asking us to do like the first bit of the question of just like turn this into the standard singleton pattern, which is this. But that is a good point. The point that I was trying to refer to is that say we leave this code exactly how it is, and it just happens that our computer is really, really slow. And this first time when we call get instance, it makes it to like this line of code, right? And then this one is called, sorry, not the first one. Say it makes it to this line of code, and then the second one is called, and it then makes it to this line of code before this has a chance to create a new instance, kind of thing. So we have the same problem that we had that we have with the rest of our system, that we have with our buy ticket functionality. So the other keyword you have to use when you do the Singleton pattern is the synchronize, yeah. And I've spelled it wrong, please. God. Right. No. Where's spell? You haven't got spell check on your computer, Nick. How have I spelled it wrong?
You spelled it right.
Oh, okay. It's fine. But yeah, so we have to make sure we remember to add that synchronized, because then we'll get that unexpected behavior when the we'll get that unexpected behavior when the like if two things try and call that method at once. Cool. So the next part of the code. So hopefully, if we now, I don't know what I've done, but hopefully, if we run the code, we get some different output than what we did before. Is that? See what happens, I guess. Did I like? Oh, wait, I've copy pasted that into there. That's why it's, I think. Hold on. Why am I, what has happened? Oh, right, yeah. That's fine. Yeah, there we go. All right. Okay, hold on. See, this is why I have spell check installed. Yeah, but you're better at English than I am, so like literally half my PRs like at work are like, you spelled this thing wrong, you should go fix that. I'm like, yeah, okay, yep. Yeah. So note to any people who suck at spelling out there, remember how to spell synchronized. Yeah, okay, so now it's not getting annoyed anymore. Let's run this and see what we've got left. So we've got a slightly better output than what we did before. Like, so unfortunately, there's no tickets left. So it's at least doing something correctly. So we're like, okay, cool. We've made a step in the correct direction. And now the only thing left is we're like, okay, well, we solved one of our problems that we realized in the first part of the question. Now we have to solve the problem in the second half of the question. And now that I have synchronized spelt correctly, I'm just going to copy paste it because we have the same problem with this buy ticket thing here. So we only want them to be able to buy one ticket at a time, because we don't want everything calling this and then this get tickets left is like outputting the wrong result. So let's make sure that's saved and run it again, and then Yeah, cool. So now we've got, there's 4 tickets left, 3, 2, 1, 0, and then 2 people who haven't got any tickets left. And now if we go back to this question here, we can then double check our expected output. So 4, 3, 2, 1, 0, no tickets, no tickets left. So it doesn't if for this case, it doesn't necessarily need to be exactly the same. It's just the idea that we're trying to get across. So is there any questions about the Singleton pattern part? The Singleton pattern is probably one of the easiest code-wise to implement. Let me just open up Teams to see if. Oh, okay. Have you not shared your whole screen, or have you? There's people saying that they can't see the code.
Oh, sorry, I thought you fixed that. Wait, you can share your comments all the time.
Yep. I didn't know that was okay. Stop sharing. Share. Okay, I'll go through the code again then. Share this one. Okay, can you guys see the code now if I go to it? Okay. All right. So sorry about that. Just for this case, let's just quickly go over the code again for the people online. So basically the main parts that you're talking about when you're doing the Singleton pattern is that you want to make the constructor private. That's kind of step number 1 because you don't want other program or other classes being able to access and just create it anyway. That's the point of this function. We want to hide this and then only allow people to create instances of our classes via this getInstance method. So basically all we did is we added this part here was just in the return. So every time getInstance was called, it just returned a new instance of the thing, which kind of defeats the purpose of having this getInstance method to begin with. Because it's the same as just calling the public version of this. And this is just a really basic example of the Singleton pattern. We create a static instance here. We then, when this getInstance is called, we check whether that instance exists. If it exists, we return that instance. Otherwise, we set the ticketing system instance to a new instance and return that instance. And then the part that I was talking about that I struggled with spelling was this synchronized, because we have the same problem that we have elsewhere in our code of we don't want 2 functions being able to access this at the same time. And then the other part is we just added a synchronized to this by ticket function. And that solves the 2 problems that you hopefully addressed in that first part of the question. Okay, cool. So let me go back to it and go back to the Confluence. And go to the next part of the question. Somewhere. Okay, cool. So we've now, that was the first part of the question. That was the 9 marks worth of stuff. And this part of the question here is normally not marked unless you kind of, the marker is like, I have no idea what this person is doing. This part here is more just so you can take notes and be like, okay, well, if you want to do any planning or anything like that, you can do it in this file. But mainly will be marking your code rather than what's inside any of these text files for the coding questions. So then the next two parts of the question relate to the code below. So consider the code from the ticketing system, which we've just had a good look at, which sends the receipts for a single ticket. So we can have a look here, creates a new receipt, you get the cost of it, you send it, and then if it wants an email, an SMS, or an address one, then it creates a new one, adds the cost to the one we had before, adds it to the message, and then does the same based on the user's preferences, and then prints it out at the end. So the first part of this question is, what design problems can you see in the code above? Now consider the code must be extended to store the receipts for multiple purchases. This would need to include all the selected receipt options and the total price. Do you think this current design easily allows for this extension? Write your answer in question 12.text. So again, this is kind of like a precursor to the question of, we want you thinking about the problems, and then the second part is go solve those problems with this specific design pattern. So the first part is that everything is done inside this, all of the like logic of the receipt creation is done inside the ticketing system class, right? Because when you go to like the shops or something, you don't want, like, when you print out a receipt, it's all should be on like the one receipt, and it just calculates, it just adds up all of the costs. And that's normally something that, you know, you just be like, okay, here's the receipt, print out all of this information. Where in this case, any time that you wanted to be able to print out the total cost of, in the current implementation, anytime that you wanted to be able to print out the current cost and the message that the receipt creates, you actually have to like call all of this code again, right? You'll have to call get cost, blah, 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 blah. And then all of it's done in here rather than done in some nice way that is extendable. Because if we wanted to add an extra, say you in a different part of your code, it calculated the cost again, right? And then in this case, anytime you wanted to like calculate the receipt, you'd be like, okay, well, it had this in it. It had extra X, Y, Z. I have to do all these calculations again, right? And that's pretty much what this question's asking about, is like, well, as soon as I add a different type of receipt, or as soon as I do something else, I might have to change my code in like any time that this is mentioned anywhere, right? Which is normally the thing that a design pattern is trying to solve. That is one of the key things a lot of design patterns are like, okay, well, you can do it this way to avoid having to go change your code in a million places later on, based on what the problem is you're actually trying to solve. So basically, if you wrote any of that stuff in here, again, for a lot of these questions, you don't have to write an essay. It's normally, if you cover the key points, you'll get the marks. If anything, if you write an essay, one, you're kind of wasting your time in the exam by writing an essay. And two, the mark is going to be like, oh, I have to read all of this, right? So, you know, make both of our lives easier by just like writing the key points of the question. Yeah, honestly, dot points are great. When I see someone's written something in dot points and I'm marking a question, I'm like, thank you. Like this is a coding course, not a can I write an English essay course. Pardon? Yeah. Yeah, there's no need to do any of that. We literally just want to check that you know the answer to the question. If you know the answer to the question, then you can show that answer however you like. So the next part is the decorator pattern. So again, this might not necessarily say go and implement the decorator pattern. It might be, okay, go and fix the problem that you would have identified in part C. And so for this case, if we go have a look at this code, again, hopefully you can immediately think, oh, okay, this is the decorator pattern because I'm just wrapping a whole bunch of extra functionality onto something that already exists, right? So I have a receipt. I want to then add wrap my cost with an extra set of receipts and then wrap it again with a different set of receipts based on the user's preferences. But say you look at this and you're like, I don't know where to start, right? What do you do if you look at this and it doesn't say, go do the decorator pattern? It says, go and solve the problem we just talked about. And so if you're doing that, the first thing you could be like, okay, so we have a bunch of the same thing. They're all email receipts. They're different classes, but in this implementation, they all need to have two functions associated with them. We need a get cost and a send. And you're like, okay, pardon? Yeah, right? So you're like, okay, in that case, let's just start by doing something and then maybe something will come to us as to what design pattern this actually is. So let me just move back to the code. Cool. So we're like, okay, well, we need two things and they need to have an interface. So let's do that. So if we open up, let me just close these, except for ticketing system. So we have our email receipt, our post receipt, and our SMS receipt. And then the actual receipt. So the first thing we're like, okay, well, there's a send and a get cost, a send and a get cost, and a send and a get cost. So we don't actually have to write any of this code. All of it's already there. But to make this code nicer to read, let's add an interface. So let's do like our receipt sender.java, and then let's put our two methods in it. So we want a public string send and we want our public double get cost. And then change this public. Cool. And they're like, okay, well, we now have a starting point. So we now know that our SMS receipt, our post receipt, and our email, all of our different types of receipts, they need to be of type receipt sender. So the next thing we can do is we can just go to all of them and we can do our receipt sender. And then copy all of these into our so at the moment, whoops, did I miss one? The normal receipt. So at the moment, what you might have noticed is we haven't actually done anything to change the functionality of the code at all. We've just added some stuff, which in the beginning might seem a bit like extra. Like we've just done some extra. It was already working. Why have we added this extra stuff? And the reason in this case that we've done this extra stuff is because say we wanted to add a different type of receipt. We want to make sure that it follows the same guidelines that we've set for everything else. We don't want to trust the user that they're going to go have a look and implement it correctly. right? We want to be like, no, we're forcing you to implement it correctly and not just trust them to implement it correctly. So the next part, so let's go have a look at the ticketing system again. So again, is say you're at this point and you're like, okay, well, I still don't know what design pattern this is, but hopefully it might have ticked over at this point that we're implementing the decorator pattern if it wasn't listed. That our we have our receipt. So the first thing we need to do is create a receipt, which has a receipt and a cost, right? But what we want to be able to do is we just want to be able to call get cost and get receipt at the end. And then all of these things should be on top of that. And so what we might do in this case is, we're like, okay, well, all of these, our email receipt, our SMS receipt, and our post receipt are all slightly different to our actual receipt. Because our actual receipt is, you have to do that every single time. It's like, yeah, you bought a ticket. You can't have any of the other stuff unless you actually have a receipt to begin with. But our other stuff is all like optional extras, right? So all of this stuff is optional extras of, okay, well, you want to also get it emailed to you or SMS to you or addressed to you kind of thing. So let's treat all of these things as the same thing. And so what we can do that, we can, if you haven't realized that this is the decorator pattern, you can call it whatever you like, but we can do our receipt decorator.java. And in this case, what we want to do is we want to say that all of our different types of receipts are of type receipt decorator, so we can treat them as the same thing. So in this case, the other thing is, what's the time? Okay. So in this case, we have this, and in our receipt decorator, we want to, basically the way the decorator pattern works is that we want to have an implementation of it needs to be of type receipt sender, but then instead of doing SMS receipts implements receipt sender, we want to actually move this part here to here, and then we can go, okay, well, all right, go add these unimplemented methods. And because now we're saying that this needs to be of our receipt decorator, we can move this. We can change all of these to be our extends this. So this is, I'm just kind of going through it in the case of you don't know where to begin, just begin somewhere, get some code down. Obviously, if you know this is the decorator pattern from the beginning, you can skip this step and just jump to, I've created this class, I've created this class, make everything accurate. But I'm just trying to, usually there seems to be some like, you know, paralysis when it comes to implementing some of the code things. Like people don't get started. Like it's normally, you know, people finish the coding question or they don't start the coding question. But, you know, we want to, where's, cool. And so now, now we have a classic infrastructure for getting the decorator pattern working. So the only other thing is that our receipt decorator, it needs to know what it's actually decorating. And in this case, it wants to decorate a receipt sender. And then we can go. Spelled it wrong. whatever. And then when we create our receipt decorator, yours doesn't have the thing. So oh, wait. Cool. I think hold on. My brain is like so tired. So sorry if I'm fumbling a bit. I had my thesis presentation this morning and my group yesterday was like, yes, so you know all that like stuff you wrote, can you make it like 3 times longer? And so I was up until 4 o'clock this morning. Oh no, that's Python, this. Yeah, cool. And then basically what we want to do is the way the decorator pattern works is that you have the thing, you then want to decorate it with whatever you're doing and then return the actual functionality. And I looked at this like an hour ago because I knew I was going to do this, and now my brain has decided to stop working. So give me a second. Pardon? Oh, yeah, sure. So yeah, but hopefully that gives you some idea of like how to, like, the point that I wanted to try get across, because hopefully you've all done this question. The point that I wanted to try get across when I was going through this is to actually, like, don't just like look at a question and go, I have no idea what I'm doing, let's not start kind of thing. Let's look at the question, see what problem we're trying to solve, and then just get some code down, and then you might get some partial marks for getting part of the way there. So hopefully all of that makes sense. Yeah, we'll post the recording afterwards, but I'll let Nick go into the next question.
Cool. So that's one of the programming questions, and I've got 10 minutes to do the second one. There is a full recording of this because from the 22T3 live stream, I think. Yeah, because this was a 22T2 question. This is like, there'll be a question that's pretty similar to this in terms of like structure and I guess the overall field of the question. So basically this question gives you GitLab and a very, very, very simplified version of it. And in GitLab, as you've noticed probably, there are these things called groups, which can contain other groups, and they can contain projects. Like in this one here, you've got like the 22T2 group, which has the staff group, which has the repos group, and then also the staff group also has the learning dashboard repo and the admin repo and blah, blah, blah. Now, hopefully, immediately you're like, that's a certain design pattern, which I'm not going to spoil it for you yet. If you haven't got it, think about it. There's a tree, that's another big hint, which contains, which I just explained. At each level, the user can have a type of permission. The only actions that require permissions are creating a project, you need developer, subgroup maintainer, and then changing permissions of another member in the group, which requires own permissions. The first thing for any sort of refactoring question is you've probably found, and hopefully we've done enough, we've drilled those refactoring skills into you at this point in the course. Oops. Sorry, there's the share screen thing. Let's go share, window. Hopefully we've drilled into that the first thing for any refactoring problem is just like to get the lay of the land and have a look at the code that you need to implement. I'm going to cheat and I'm just going to delete this. Delete this as well. Let's start. Authorization exception. Okay, this is pretty chill. This is an exception. GitLab factory. Okay, maybe that's important. GitLab group. All right, well, we talked about a group in the spec. Let's have a look at this. Okay, a group has a series of members, subgroups. We can have a creator, get users of permission level. All right, looks fine. Update user permissions, create subgroup, create project, authorize, to JSON. All right, to JSON, yeah, you're familiar with that. That was in lab 2. Cool, what about permissions node? Okay, that's an interface. And we notice that group implements permissions node. Awesome. All right, GitLab project, that's also a permissions node. Has a series of members. You think, oh, that's kind of weird. We have members in GitLab project and GitLab group. Okay, probably a code smell. Might have to refactor it. Blah 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 blah. Update user permissions. Oh, we're doing more authorization. I think I've seen this authorization function before. That's interesting. Okay, more repeated code. Then we've got this run pipeline and to JSON. Okay. GitLab runner. Not much going on there. Permissions level, that's just an enum, and then user, that's a data class, might be a code smell, we'll see. Okay, what's the question asking us to do? That's not what I wanted. What's happening when you try to do stuff too fast? Okay, code analysis, all right. Look at the code inside the GitLab package. We did that. Answer the following questions. Explain what design pattern is being used to represent the system and how the domain relates to the key characteristics of the pattern. Shout out, what is it? Composite pattern. Yep, you see the words tree, leaf node, compound node, composite pattern. How the domain relates to the key characteristics of the pattern. Okay, key characteristics of the composite pattern are, what are the compound nodes? What are the leaf nodes? I think that's really it, to be honest. And the idea that you can have maybe like compound operations, but the main thing structurally is that you have, again, groups, which are our compound nodes, and projects, which are our leaf nodes. That's all well and good. So 1 mark for composite pattern, 1 mark for explaining how the characteristics map. Identify what you think is the main design problem present in the existing code, including what smells are indicating the problem. I don't think I remember when we did this question, like people love to overcomplicate it. Just like keep it simple, stupid. You know, it's 2 marks. It's like we saw this when we looked at the code, right? It's like there's some repeated code. We've got a dry problem. That's all you need to say, and maybe give some examples, including. So that's the smell, right? The dry is the smell, and the design problem is, okay, well, what could be causing dry? Let's have a look. Oh, sorry, I've just shared the same thing twice. Code, all right. So we have this code in project and permissions, and that's implements permissions node. We have this group. Okay, that also implements permissions node. So we've got 2 subclasses. Let me use the whiteboard. We've got 2 subclasses that both implement this interface. But then there's repeated code within both of them. What can we do here? Well, we can't put, we want to sort of move the code up to a common point, right? We've got to move the code into the interface. We could do that maybe using default methods, but probably a better thing to do would be to use an abstract class instead. We could turn this interface into an abstract class. That's not what the question's asking though. The question's asking what is the underlying design problem, and that's what we identified just now. Of there's common code in 2 subclasses of a similar type. Okay, let's solve that problem. And this is part C of the question, which is asking you to do refactoring. Now, when we ask you to do refactoring, and I think Sienna mentioned this as well, is like we will test to an interface. So we've given you like these tests in GitLab test, and we've given you regression tests. So if you run these, they will all pass. If you are failing these tests, something has gone wrong and you need to control Z and it'll probably just mean you've accidentally screwed up the interface. So it doesn't matter what happens, Earth ends, you've got to keep these tests passing. What that means is and I remember when we did this question, a bunch of people were like, okay, here's the refactoring changes I want to make, but then they will break the interface. So you're kind of constrained to a certain set of changes, which is fine. The changes that this question is asking you to do, or that this question is intending that you do, mean that you don't have to change the interface. So we said we'd turn this from an interface into an abstract class. Sorry, I might disambiguate there. Interface in the sense of we test to an interface is a generic term in that we test to these methods basically. It doesn't matter whether it's a Java interface or an abstract class, but as long as you don't break that, then it's fine. So let's do it. Abstract class. Now immediately this is all going to complain at us. Get name, blah blah blah. Let's go and take all the common stuff out of group and permissions nodes. We had that members list that we were talking about before. What else do we have? We had that authorize method. We're probably two JSON, I think, is similar as well. Let's split right. Okay, get user permissions, create subgroup. I'm looking at the same file, that's why they're the same. Okay, get user permissions, we can get rid of that. Create subgroup and create project. Okay, update user permissions. Now we need to start thinking here. It's what stuff is the same on a group as it is on a project, and everything to do with the permissions will be the same. It doesn't matter whether it's a leaf node or a compound node. The functionality will be the same, and you can see that by the fact that the code is the same in both classes. So we get rid of this. Now, create project and create subgroup mean different things in different contexts. So, authorize something else we can move. So I'm just going to skip over those for a second. Get rid of this. To JSON. Now, to JSON seems. Yeah, we can keep that. That's fine. We don't need to move that up. So create subgroup and project. When we create a project in a group, we authorize and then create a new project object and then add that, and then same thing in the group. But notice when we try to create a new project within a project, that doesn't mean anything. We just return null. And you're like, well, that kind of makes sense because I can't create a project inside a project in GitLab. That's what it means to be a leaf node, right? You don't go any deeper in the tree. And that's something else interesting as well. And you're like, well, the fact that these methods do nothing is kind of a bit weird, but then if I get rid of them and we go to the tests, you see that these regression tests start to break. So maybe that's something we just have to kind of live with, at least for the time being. Now here we have this other problem that we haven't actually figured out what we're going to do here, and we're just going to say let's mark these as abstract. Say public abstract GitLab group, which means as the abstract class, not my problem. It's up to the subclasses. They have to go and implement it themselves. And you see that mostly pacifies everything except for GitLab group. Create subgroup. What am I missing? Must override or implement. Oh, I just not save this. Okay, that's good. This should extends. Woohoo! We fixed our compile errors. We've still got this members map in the permissions node, which is giving us a bunch of problems. That's a bit strange. We need to get rid of members from here. Now, subgroups, a project has no subgroups, so that is specific to what it means to be a GitLab group, so we're going to keep that there. This is going to extend permissions node. And then we're going to move this. Also the name, we can move that up as well. Private string name. And then we'll just copy the constructor. Members.put map import. What's the problem? Public string get name, return name. I've kind of made a bit of a mess of this file. I would reorder some functions to make it a bit more clear. Get rid of the overrides because we're in the superclass and make this abstract. That's it. Happy days. Except for this one, which is still complaining at us. Implicit super constructor, blah, blah, blah. All we need to do here is say super name owner? No. Where does the owner come from? Oh, I see. It's the creator. Now, is that code compiling yet? Not yet. We're almost there. Sometimes, like this is just a jigsaw puzzle of, you know, getting code to compile, which is better than trying to get your code to, like, not have bugs, but it always compiles. Let's just chuck this here. GitLab project, implicit super constructor. What do you mean? You were working fine a second ago. Okay, that's fine. Public class. The super interface must be an interface. This is not an interface. Oh, here we go. Implicit super constructor. Public GitLab. And then the last thing I think is just fix these imports. All right, we're almost there. Authorize. Now this one, authorize is private, and we're trying to access it from the subclass. So I'm going to cheat and say protected. And then that works fine. What method authorize is not visible? I have to say super.authorize. Okay, that's fine. Oh no, it's fine. I think my VS Code today is being slow. Okay. Sorry, I haven't coded this course all term, so I've forgotten how to use VS Code. That's great. Now, how do we know if it worked? Well, let's run the regression tests and see if they all still pass. So again, no functionality's changed. We've just improved our code quality, and the regression test failed. So we have not improved anything. Expected 22 T2, but was null. Oh my god. What happened? Okay, we passed in the name. Stream name, stop name. GitLab group. Oh. Expected name, but none found. That was weird. Subgroups 0.subgroup 0. Maybe I forgot to remove it from. Oh, I did. Okay. Very sneaky. Local variables causing problems. Woo, now we pass. Okay. So that's all the refactoring done. And all we did was just what you did back in lab 2 in the hotel exercise, where you take the code in the subclasses and then you move it all up into one big abstract class, and we reduce the repetition. Now, I'm gonna skip parts of this because there's a part about Singleton. We've already done that. There's another part about oh, sorry, I skipped this, and I think I also skipped this. Okay, I'm going to skip the filtering authorization. You can watch last term's recording if you want to know how to do that. I'm going to skip the factory pattern. You can watch the recording. I'm just going to go through refactoring a method and this part here. So, which of the following design smells is also present? We talked about how, and this is pre and post refactoring actually, because we said, okay, we can't change the interface, but we have this create project and create subgroup method that is sitting on GitLab permissions node and sitting on GitLab project specifically. And you notice here we've still got this return null, return null. We tried to delete it, we couldn't because that would break the interface, it would break the regression tests. But this is an example of refused bequest. So bequest is like when I say, okay, I bequeath you this thing. You know, it's like the like those sort of Arthurian stories where it's like I bequeath you the sword of blah blah blah. In this case, I can't speak. In this case, the superclass or the abstract class says I bequeath you this method that you have to go and implement because it's not my problem. Which in this case are all these abstract methods. And the subclass says, well, that's not really relevant to me. In this case, it's like, well, creating a subgroup or creating a project on a leaf node don't make any sense. This is a design trade-off we've had for uniformity across the different classes, so we have it all under the same GitLab permissions node. And this is a trade-off that you see quite commonly. Either you get uniformity or you get type safety. And this isn't like super type safe because we get this weird return null thing, which is a bit annoying. But it means that we have this consistent interface. So again, that's a trade-off. Being able to recognize it is all you need to do here, and just say refuse bequest. Now, the refactoring a method, there'll be a question like this. This is basically just like, can you do streams? You'll get a method and it'll be something along the lines of this, where it's like, okay, here's some operations that get performed and you have to refactor it to use streams and you have to keep the regression test passing. So let's do that really quickly. I think we moved it to GitLab permissions node. Yeah, here it is. Okay, so we have a members set, and then we go through all of the members in the members set. And then I think members is a map, right? Yeah, members is a map. So we get all the keys and then go through each of them. And if we say, okay, well, if looking up the key, the value, which is their permission, so each member is associated with a permission, if that is the same as the permissions level that's given, then we add their name to the list. So we can simplify that using our great friend Java streams. So I'm going to say return members.keyset. So first thing we do, same as here, and then we're going to turn it into a string. Now what I want to do is for every item in the stream, I want to say dot filter, and we'll call this m.getName dot equals, sorry, that's not right, m.get, members.get m, so we do the lookup dot equals level dot map. So we filter all of the members that aren't of the same permissions level, and now we want their name, so we say map. Now there's a bunch of ways you can do this. This is the syntactically easy way. Say m.getName, which gives us back a string. Or if you want to be fancy, you can do this. You say user : getName, and that just says run the getName function on this user, which is our member type. And then once we've done that, we can collect collectors.toList and bunch all back up into an array. And that's it. Now, I don't think there were actually any regression tests testing this, so you were okay on that front. But as long, like, if you did this, then you got full marks. If you did some like slightly more, like I saw a bunch of people that did like one loop and then they did partial streams, you get partial marks for that. But this question is not too hard. If you understand filter, map, all that stream stuff, then this is a basically free 3 marks. And on that note, I usually go through some like advice about the exam. I think this term, because it's all like in-person closed book, we'll obviously like adjust the exam to accommodate for that. What else? What advice do I have? Other than just like know the content and the stuff I said before about like, you know, sometimes it's not like how much can you regurgitate. It's just like, can you look at a problem and come up with a reasonable solution? Yeah. For more detailed stuff on a bunch of these questions, you can watch the previous recordings. Otherwise, I think that's everything. Do you have anything else you want to say?
I added all the combined lecture slides, so if you really want to and you get stuck, you can Command F all of the lecture slides.
Do they
added that to the update one to the files that you get access to.
Okay, cool. Okay, so you do get access to the lecture slides in the exam.
Yeah, you have access to that.
Cool. One other thing, the lecture code, cool. Please make sure your code is compiling. We had a bunch of problems last term where people, particularly for the design question, which we didn't cover today, but is the question where you need to do like the API. You just do the interface. You don't actually do any coding. You just come up with what are the functions, what are the fields, all that sort of thing. And do check out last term's recording where I went through that in a lot of depth. Please don't write code, you'll just waste time in the exam. But for that question, a lot of people like wrote code, or they wrote something and then it didn't compile. And because of how Java and Gradle projects work, which you by now probably know, having dealt with them all term, it's like you have a project and you have one file and that project's not compiling, the whole thing doesn't compile, which means when we run auto marking, none of your questions compile. So we had a bunch of people who lost marks last term because they just didn't have their code compiling in the design question, and then they'd done all the coding questions properly, but then their whole thing didn't compile, and that caused a bunch of problems for students. So please make sure your code is compiling. Please just run Gradle test. If your tests are passing, that's good. Even if they're failing, that's fine. Your code just needs to be compiling at the very, very least. We'll mark your code manually either way, but when it comes to correctness, make sure your code compiles. Cool. That's everything I wanted to say. Thank you for coming. Thank you for watching the recording. Thank you for coming in person, and good luck. We'll see you.
The exam's tomorrow. Good luck.
Yeah, if the exam's tomorrow, yeah, good luck. And we'll see you bright. Is it afternoon or morning? Okay, we'll see you in the afternoon, all relaxed and ready to go for the exam. So good luck for that. See ya.